Okay, here we go. 13. The instructions for this sheet, if you look on the very front of the packet, it says find the limit for every problem as specified. It also says identify any horizontal asymptotes. So far, everything we've talked about is simply about understanding x and y. When we find a limit, all we're doing is saying, okay, if the x coordinate is going to grow forever, please use this formula to calculate what y value we would end up with. It's always just about x versus y. So we're doing this limit problem. When you have, okay, so the previous homework was all about talk about continuity. And we did limits in order to understand what's happening as far as continuity versus discontinuities. Today's homework won't say anything about continuity. It just talks about finding limits themselves. So when I see just a limit problem, I use what I call the limit flashcard. So I would highly recommend that you put this on a card or in your notes. Whenever you're asked to find a limit, the first thing I always do in this class is I first identify if it is a limit where the input variable of the limit is going to either positive or negative infinity. So first thing to do is look and see, do I have a limit where x, or whatever the input variable is headed towards infinity? Number 13, that is what's happening. We're finding the limit as x approaches infinity. So because x is approaching infinity, what I'm going to do next is I'm going to make a comparison amongst the terms in the formula that are adding. That's kind of redundant because a term is defined to be something that is being added, but we all tend to forget that, so I add a couple of words to hopefully make it easier to remember. So when you look at the green box, we need to look at top and bottom separate. We almost always do that, look at them separately. When I look at the top, I see terms. I see things that are being added, and I see 3 of them. So I have 15x to the 15th power. That's being added to a positive 5x to the 14th power, which is being added to simply the number 2. So I see 3 terms in the numerator that are being added. Now I can do something pretty simple. I say, well, if x is going to grow forever, and I've got these 3 things added together, the 2 is not going to make any difference at all, really, because x just keeps getting bigger and bigger and bigger. As x gets bigger, the purple and the blue term just grow very rapidly. Pretty soon it doesn't even seem like I'm adding 2 because of the difference in size. It's really similar to, like, literally visualize the Earth. Picture that you have a way to measure the weight of the Earth. And then suddenly, like, oh, let's change it a little bit. Let's put on the Earth 1 ant. The weight of the Earth will change, but not by anything that would be even hardly measurable. So anyway, so that's what it means to compare terms that add. We pick the dominant term. The dominant term is the purple questions, because it is the highest power of x. And then you're going to write on your paper. We've got to have good notation again. We'll check for this again. So good notation. And I get that it can be sometimes a bit tedious to use the good notation, but you have to get the habit. Half of the AP test is written. If you don't develop the habit today, you won't develop it in April. I've seen it. Like, people just, it's just a disaster. Like, they don't earn any points on the written section because they just have such bad habits. So I'll keep paying you for good habits. So we write equal. Don't leave off the equal sign. They will take away points. If you don't have an equal sign, they can't follow your work. So we say this limit's equal to this limit. But now we can create a much simpler limit problem, because after we compared the terms they're adding, we realized that really only the 15x to the 15 is of concern to us. Questions? Okay, simple extra credit points. I just want to give away some points, so here's what you do. Look at the denominator on your hand. This means 0, 1, 2, 3, 4, 5. Show me how many terms there are in the denominator. I'm just giving away points. These are not hard questions. So just like this, show me how many terms are in the denominator. So 0, 2, 3, 4, 5. Show me. Okay, everyone gets a point for voting. There are 3 terms in the denominator. There are 3 expressions that are being added together. It's purple, blue, and orange. Sorry, orange. Okay, notice how it's super critical that you think of them as being added. It's not 3x to the 15th subtract 8x to the 13th. It's 3x to the 15th plus negative 8x to the 13th. You have to think of them as being added, otherwise this method doesn't work. Questions about anything? Please.
So just for clarification, on the top, we're only keeping 15x to the 15th just because it's so much bigger to everything else in comparison?
In comparison, when x grows forever.
Okay.
And I'm simply asking you to memorize that. I haven't done anything to prove it. I'm just telling you that's a memorized fact that we'll use. 2 more for Carrie. Anybody else? Sweet. On the bottom, by the similar idea, the dominant term is the 3x to the 15th. Questions? Okay, the next item on the flashcard says we should always factor and divide. Look, up here, we were working with terms. Now we're working with factors. When you have factors, you can break them up into separate fractions. It makes it a lot easier to see exactly what's happening. So I'm going to rewrite this one more time. Everybody write what I'm writing. We have 15 over 3 multiplied by x to the 15th divided by x to the 15th. Now it's extremely easy to see that no matter how large x becomes, this fraction will be some large x value to the 15th power divided by the same large x value to the 15th power. Something divided by itself is always equal to 1 unless you have 0 divided by 0, which is undefined. We don't care about 0 divided by 0 because we are investigating what's happening when x gets larger and larger. So we know that the blue box is definitely equal to 1. You'll notice the sign here. I'm really big on don't use this foul language in my room. So, most teachers on the whole planet use that foul word, and I feel like all it does is cause students to actually make mistake after mistake after mistake because they lose track of what cancel really means. In this case, I'll never say that these cancel. I'll always say they divide to make 1. Questions? Thanks to Lindsay Worthen for the nice sign. So. All right, this is going to be 1. 1 times 5 is 5, so the value of this limit is 5. Raise your hand, please, and answer this question. Is the 5 an x-coordinate, a y-coordinate, or something else? Hands up. Is the 5 an x-coordinate, a y-coordinate, or something else? 2 points if your hand is raised. They're asking us to think about what happens when the x-coordinate grows forever, and they're giving us a formula for computing the corresponding y-coordinate. The formula here is not identical to this formula because we made some assumptions, but if x is very large, they are essentially identical formulas. So we had a formula here for finding a y coordinate. So we know that for this xy relationship, which is all we ever study in this class, when x gets really, really big, y gets really close to equaling 5. Question? Okay. As far as good notation, you really don't have to write both of these lines here. As long as you write one of them, you'll be fine. I wrote both just for clarity, but you don't have to write both. Now we're supposed to do something separate. We're supposed to go find if the function has any horizontal asymptotes. So you need to have this on a flashcard. If you're asked to find a horizontal asymptote, that means you're asked to find the limit as x approaches infinity. On my flashcard, I would only write this much, because the rest of it's just the regular limit flashcard. So you don't need to have this on the card. You just need to remember, oh yeah, if I'm trying to find a horizontal asymptote, I am finding a limit as x approaches infinity. So I have this on one flashcard. For finding any limit. And then I have this on another flashcard to remind me that if I'm asked to find a horizontal asymptote, I'm simply finding a limit as x approaches positive or negative infinity. Just letting everyone get caught up on the notes. Anytime in class that you need another moment to write something down, it does not bother me at all if you simply raise your hand and say, hey, can I have just a minute to write? It's totally fine. Questions about anything? Okay, so the next thing I write on my paper is I've got to find another limit. So I'm finding the limit now as x approaches infinity. Okay. But I've already done that for positive infinity, so I don't really need to do that again. In fact, I could, let's back up here. I don't really need to do it for positive, I just need to do it for negative. So I've already done it for positive infinity. I don't need to start over here, because the idea of comparing, if all we're doing is comparing power functions, these are power functions, the comparison is the same whether x is getting very, very positive or x is getting very, very negative. The highest power function will still dominate. So I don't need to use this complicated formula. I can skip to this very, very easy formula, which really, okay, this is looking way too easy, I'm writing too much. I don't need to write this at all. I can just say, okay, got it. As x approaches infinity, I figured out that y was going to approach 5. But if this were x approaching negative infinity, this formula would still be the same. So this would still equal 1, and I get the same result. X approaching negative infinity, y would also approach 5. Therefore, I have a horizontal asymptote at y equal 5. Not x, but y. And that's all you need to do for this problem. Questions about anything? Please.
On the test, you would write out horizontal asymptote at y equals 5, or is h a and the set x equal
3 points for that question. I would write it out. Yeah, there's quite a few abbreviations that they accept, but that one I would write it out on the test. Question? Sweet.
If we have to separate them and try and find like positive infinity and negative infinity, do we have to do what we did before, where we put a plus next to the infinity and a minus next to the infinity, like to clarify that, or
Yeah.
just remain as is?
to be fair, I think you would need to write one of these two orange statements in order to make sure you didn't make a mistake. The rest of it you can do in your head. You actually don't have to write it out. Is that what you meant?
Yes,
Kind of.
actually, that does answer one. But do we need to put like a plus to say that's positive? Because
Oh,
we're
yes.
doing after like the previous limits, like x positive.
Oh, different question. Two more. When x is approaching infinity, there is no left-right limit. Because it doesn't mean the same thing. It's like x just grows forever. So there's no left or right.
So we don't have to.
Don't worry about that. All right, let's do a different one. Let's go to, remember, let's stop there.